Okay, today we're going to be learning about applying properties of logarithms to help us simplify logarithmic expressions or expand them to make them easier to solve certain types of problems later on. So these properties that are right here that we're going to be learning about first, these really stem straight from our properties of exponents that we learned in the last unit. As you'll see, remember, because a logarithm really just represents the exponent. Whenever we see a logarithm, we're asking what is the exponent on this base. So whenever we do these properties, you'll see they're kind of the same. So I'll remind you of a few of the properties that we learned before, and so you can see how they really are somewhat the same. So if in a logarithm I have a base of b and it's giving me two things right here that are being multiplied, well, we can just split those up into two separate ones. So this is called the product property. And if you remember, we have a product property in exponentials also. If we ever have the same base and we're multiplying them, well, we just add the exponents. Same thing here. If I ever have a logarithm where we're multiplying within the logarithm, then it's really, we can just add the two logarithms together into two separate ones. It's like we're adding the two exponents. Same thing with the quotient property. If I ever have two things being divided, or I can write it as a fraction, right? Before we had something like this, where if I have one exponential divided by the other and they have the same base, well, we can subtract the top minus the bottom. Well, same thing here. Whenever I have a logarithm, we can subtract the log of the top minus the log of the bottom. And then lastly, we have the power property, which is basically if I ever have an exponent on here, that's the same thing as just multiplying it by the front. As you'll see, we can just bring that down to the front whenever I have an exponent. So they switch back and forth. And that comes from the power property of exponents, where if I ever have a power of a power, so an exponent on an exponent, right, an exponent on a log, well, we can just simplify this by just multiplying the two exponents. So we're going to see how these kind of work out. So there's two words, though, that you need to know. One is called expanding, and the other is called condensing. So if you remember, expand kind of sounds like it's to make larger, and condensing is to make smaller. Well, we can go either way, and you're going to see examples of both of these below. So here, if I ever want to go from one log into multiple logs, that's called expanding. So that's going to the right, right? It's going from one log into multiple logs. We're expanding it to make it longer. Then there's the other direction. If I go from multiple logs and I want to turn it into just a single log by simplifying it, it's called condensing. So let's just see how these work out, and we're going to apply these properties of exponents on here. So the first thing we see is I have a log base 10 if it's not there, and I have a 3 times x squared. So what I want to do is start applying these properties. Well, since I have a 3 times x squared, we can separate the 3 and the x squared into two separate logs by the product property. If I have two things being multiplied, I can separate them into two separate logs. So I'm going to take the log of the first thing, which is the 3, the log of the second thing, which is x squared, and when it's multiplication, I'm adding the two logs together. We're adding them together. So I expanded log of 3x squared to log of 3 plus log of x squared. The other thing we have here is that this exponent on top. Well, just what we saw in the product property, if I ever have an exponent on a log, you can just bring it down to the front. And we're left with our final answer of log of 3 plus 2 times log of x. And now it's fully expanded. This is our answer. Let's try another one here. Here I have log base 5 of 2x to the 5th over y squared. So we're going to try and expand the product and quotient property first. So notice I have a times here and a divide or a fraction here. So anything on the bottom is what's being subtracted. Anything on top, which is being multiplied, is what's being added. So I have three things, the 2, the x to the 5th, and the y squared. So I have room for three separate logs. One for the 2. Then it's plus, because I have times x to the 5th, so that's log base 5 of x to the 5th. And then since the y squared is on the bottom, we're going to subtract that one, log base 5 of y squared. Right? Then the other thing we need to do is take care of any exponents and just drop them down to the front. Turn it into multiplication. So our final answer is log base 5 of 2 plus 5 times log base 5 of x minus 2 times log base 5 of y. And there's our expanded answer. So we have a special logarithm that we haven't learned about yet, but we're still going to do this example. Just pretend this is log. ln is a special log we'll learn about next time. So treat that ln as a log. So we're going to do the same thing here. What do I have here is a 2, an x, and a y to the 5th. So how many logs are we going to have there? Is 3. I'm going to write it as ln of 2. It's all multiplication, so it's all going to become plus ln of x, and then plus ln of y to the 5th. Then just like before, any exponents, we're just going to drop down to the front. And we get this the same, but the only difference is now I have 5 ln of y. And last one here, I'm going to expand this one. I have a times right here, so it's 64 and x squared. So let's separate those into the 2 separate logs. Right, so I have the 64, and since it's times, it's a plus sign in between. And then finally, we'll drop that down into the front. And not only that, but here is actually a log that we can evaluate very easily. I know what log base 8 of 64 is. The exponent on 8 that gives me 64, well, that's just 2. So if you can ever evaluate it easily without a calculator or looking it up, put that actual number there. This becomes a 2, and this becomes a 2 times log base 8, forgot the 8 there, of x. There we go. So that's expanding logarithms. Multiplication turns into addition. Division turns into subtraction. Drop the exponents down to the front. Alright, so let's look at example 2. This one has the wrong directions. This should say condense. So now we're going to go the other direction. So if it says condense the following expressions, now we're going to take multiple logarithms and turn it into just one logarithm. So if you ever write the logarithm more than once, you're doing it wrong. We only want one logarithm at the end. So first, we're going to go backwards, just like how we did the exponents last. That's the first thing we're going to take care of. These numbers in front, let's pop them back into the exponent. And I'm left with log base 4 of x to the 7th plus log base 4 of y to the 5th. And now that I have those back on there, we can condense these 2 logarithms back into a single log base 4. And inside that log base 4, all the pluses turn back into multiplication. So I'm going to have a x to the 7th times the y to the 5th. Right? So these 2 things are going to be multiplied, which we just do by writing them next to each other. And there we go. It's all condensed back down into one log. We condensed it. Right. Next one, we have ln, which again, like I said, just treat it like as if it says log. It's a special base that we'll learn about next time. So first thing we're going to do is take care of all these exponents. So the 1/2 goes back up there, 2 goes back there, 3 goes back there. Have ln of 9 to the 1/2 plus ln of x squared minus ln of y to the 3rd. Now here, I know what 9 to the 1/2 power is. Remember, this is the root. So if you can ever simplify those types of numbers, right, whenever it's a number that we can simplify, just go ahead and simplify it. So 9 to the 1/2 power, that's 3, because the square root of 9 is 3. And now we can condense it all into one single log. So 3 of them are going to turn into one log, which is ln. And inside that log, I have multiplication here because it comes from addition. This is going to be on the bottom because it has a subtraction. So on top I have 3x squared. On the bottom I have y to the third. And there's our answer. Letter C, do the same thing. We're going to put everything, all the exponents first. So it says ln2, just treat it like it says log. Let's put those exponents back on. I have ln of 18 plus ln of 1/3 squared and ln of x. So again, if it's ever a number you can simplify, go ahead and simplify this. This is going to be 1/9 because 1 squared is 1, 3 squared is 9. And now we have 3 logarithms that we're going to condense into one logarithm. And they're all addition, so it's all going to be inside the logarithm with a multiplication. So 18 times 1/9 times x. And of course, again, if you can simplify the numbers, let's do that. 18 times 1 is 18 divided by 9 is 2. So this is really just ln of 2x. And last one, pop those exponents back up there. We're left with log base 5 of x squared minus log base 5 of y to the third. Then of course the minus again moves this to the bottom, right? Minus is division. So this goes into a single logarithm, not 2 logarithms, 1 logarithm. And inside that 1 logarithm I have an x squared on top and a y to the third on the bottom.